This is a demo on post-quantum cryptography PQC using liboqs library, open quantum system, and encryption algorithm AES 256 GCM using OpenSSL 3.6. These two algorithms are quantum resistant, which means as quantum computers are evolving, the classical cryptography like RSA, ECC will fail to protect the data from quantum computers. Hence, there is a need to shift to post-quantum cryptography PQC and AES 256 GCM. These two algorithms are quantum resistant and it helps in safeguarding the data from quantum computers. PQC can be subdivided into two main categories: key encryption management, which is mainly used for encryption and decryption, and signature scheme, which is mainly used for signing and signature verification. There are many algorithms under these two categories. AES 256 GCM themselves provide data integrity with the use of AHAD authentication header with associated data. AES 256 GCM is sufficient to encrypt and decrypt the data, whereas PQC is a replacement for classical cryptography such as the RSA, ECC. There are two use cases in this demo, which I will explain after the demo. This is written using C++ by making use of liboqs library and OpenSSL library, as shown in the code here. Let's jump into the demo. There are three main applications: one for creating the PQC key pair and another for encryption, and then finally for decryption the data. I have two main files to encrypt and decrypt. One is just an ordinary text file and another one is a logo. Let me first create the key pairs by calling create key pairs. There are two pairs of keys generated. One is public Kyber512 and another one is secret Kyber512. This is mainly used to generate the AES 256 GCM keys for encryption and decryption. And another is public dilithium2 and secret dilithium2, which is mainly used for signing and signature verification. These two public keys can be later stored in the PKI public certificate, which can be distributed to others for others to use it, whereas these two secrets should be stored in your secure key vault. I have not created any certificate, rather I will try to use the key directly, but in reality we must deploy these keys in the form of security PKI certificates and store the secret in the secure vault. Let me first encrypt the document 1. For this we need to use, we will call encrypt data and the document to encrypt it. I will use the same keys just for the demo purpose. In reality, we use others' key in order to encrypt the data. In order to encrypt document 1.text, we will use public Kyber512 key. In reality, we use the public key of some other person whom we want to send the data, and we'll sign it with our key, secret dilithium2. It successfully got encrypted. Let me open the encrypted file here. Select notepad. The document is now encrypted. It contains gibberish data and encrypted data. Now I will delete the original file. Let me decrypt this encrypted data and recreate the original file. For this we need to call decrypt data and then the encrypted file. Since we encrypted using the public key, we must decrypt it using the secret key, secret Kyber512. In reality, whoever gets the encrypted file which was encrypted using their public key, they should use their secret key. Now we must verify the signature using the public key dilithium2. In reality, we use the sender's public key dilithium2 to verify that the person who sent the data was not modified in the middle of the process. Now we'll decrypt this encrypted file. It's successfully decrypted. Let me open this newly created original file. It contains the same text. Now let me repeat this process for encrypting and decrypting an image file. Let me clear the screen. First we need to call encrypt data and then the image file. We encrypt using the PQC public Kyber firewall, and then we sign it using the secret dilithium 2. In reality, we don't use this raw key. Instead, we use the certificate in the place of public key, and we use the vault in the place of the secret key. Let me decrypt this file. Let me encrypt this file, and the file got encrypted. Here is the encrypted file, and you cannot open this file as it is encrypted. Let me delete this plain text file, an image file. Even if I try to open in the image, let me open and show you. Let me open in Paint and show you. It failed to open. Let us decrypt it. For this, we need to call decrypt data and an encrypted file. Since we encrypted using the public key, it should be decrypted with the secret key or the private key, Kyber firewall, and it should be, the signature should be verified. For this, we need to call public dilithium 2. And it successfully generated the image file again. Let me open this the same way. Let me open it in the Paint. Yeah, it got open. Let me try to open this encrypted file again. Using Paint, and it failed because it's an encrypted file. Let me quickly show you the code. For creating the key pairs, we use OQS KM key pair and save it in the file, and we use signature key pair and save it in a file. In reality, we store the public key, PKI certificates, and the secret key should be stored in a secure vault. In the encrypt data application, so I make use of this KM encaps, which generates the AES 256 GCM key in the ciphertext. In the UNAES in this variable, and this is used to encrypt the file. The same way, this code signature verify, which generates the same secret key, which will be used to here it is used to verify, and then here we create the shared secret, which is nothing but AES 256 GCM key. There are two main use cases. The first use case is PQC encryption for the third party. Suppose Alice wants to send a document, so he has to protect the document and send it to Bob. Both Alice and Bob generates the two pairs of key, one for the encryption decryption, another for the signing and verification. Alice encryption decryption key is not used here, only for signing is used to send the document. Whereas for Bob, he also generates two pairs of PQC key, one for encryption decryption and one for signature verification. The signature verification is not used for Bob. Only the encryption and decryption keys are used, means the public key and the secret key. The first thing which I have not shown in the code is the public key are put into a PKI certificate, whereas the secret key are stored in the secure vault. Now Alice has a plain text. She wants to send the document to Bob. So first she needs to protect the document. She sends the plain file into a PQC encryption. The first thing it does is does PQC encryption. It takes the Bob's public key, which generates the AES 256 GCM key, which is called data encryption key, and using this data encryption key, it is encrypted, and Alice's secret key is used to sign the document so that Bob can verify the integrity of the document. The document should not be modified by any man in the middle attacker. Now Alice gets the encrypted file and sends it to Bob. Now Bob sends this encrypted file for decryption logic. The first thing is the document should be verified whether the document data is not tampered, means is not modified by any middle party. So first thing, it takes the PQC public key and verifies the signature. Once the verification is successful, he uses his own private or secret key, PQC secret key, which generates the same AES 256 GCM key which was used for encryption, and the same key is used here also in the decryption logic, and it decrypts and outputs the plain file. The second use case is as follows. as shown in this diagram. Now Alice wants to protect the document and store it in her local, either in local disk or in the cloud. So Alice first generates the key, two pairs of key, one for the encryption decryption and another for signature, signing and verification. The public key are exposed as a PKI certificates and two private secret key is stored into her secret key vault. Now after the key is generated, now Alice sends the plain text file to the encryption logic. The first thing is like PQC encryption is called. For that, if you trace the color here, Alice encrypts it using PQC public key. So it takes the PQC public key and pass it to the generate the session key, which generates the AES 256 GCM DEK data encryption key, which is encrypted. And this document should be signed using PQC private or secret. So directly it is signed and then the file is protected. This file either can be stored in your local or in as a backup in the cloud storage. Now later in the process of time, Alice decides to extract that file and decrypt it. So the protected file is first sent to the decryption logic. The first thing is it needs to be verified whether the data integrity is correct or not. For this, she uses, if you trace the green line, she uses her public key and verifies the signature. If the signature is correct, she uses her PQC private or secret key, which generates the same AES 256 GCM which was generated for encryption, and the same key is used for decryption, which outputs the plain text file. There is a redundancy in this encryption method. As I said, AES 256 GCM itself is sufficient for quantum against the quantum computers. The redundancy is using the post-quantum cryptography. There is no need in this situation to use this PQC. Just AES 256 GCM can be used. Means there is no need for Alice to generate or use the PQC public and secret keys. Thank you for watching the video.